All right, so this is LeetCode 49. It's called the group anagrams. So given an array of strings, strs group the anagrams together, and then they want us to return the answer in any order. So it doesn't matter the order of these outputs right here. So this can go over here. As long as they're grouped together, that's fine. And then they give us a small definition. It says an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Okay, so yeah, so if you're kind of unfamiliar with what an anagram is, there's a definition here, but I think it would be good to go back and maybe solve this valid anagram problem. It kind of gives you a sense of how to actually find anagrams using some code. And but this one's just kind of like a continuation of that problem, right? It just adds a little bit more complexity. So so we have this input, right? Let's look at example one. We have this input, and they're just these different words, right? And some of these words are anagrams of each other, basically meaning that, let's take an example. So this is our output, right? This is what they want us to output. So nat, this nat right here, and tan are anagrams of each other. How do we know that? Is because we have one N, one N, one A, one A, one T, one T, or more simply, basically kind of what the definition says is that you can rearrange these words to get this word. So every letter in this word exists in this word, and they're the same amount. So they're just like jumbled up. They're just the characters is jumbled up. They're the same characters, but they're just in different positions. Hopefully that makes sense. And so we're given an array with strings in it, and they want us to group the anagrams. So nat, just right here, will go here, and then tan will go here, and then so on. 8 will go here, eat will go here, and then T will go here, and so on. I think you're getting the idea, right? And then bat goes over here by itself because there's no other words that are anagrams of that word. Okay, so how can we actually do this? How can we get this final output? So typically, actually, for this other valid anagram problem, we sacrificed on some space so that our time would go down, and that's kind of what we're gonna do here. We're gonna have to use some space so that our time complexity won't be outrageously big, but it'll still be. This is one of those problems where like you just really can't get that great of a time complexity, but oh well, this is just one of the LeetCode problems, right? This is probably nothing that we might solve this in real life, but anyways, so how could we do this? So we're going to, what we can do to actually identify anagrams is we could sort the string, right? So if we sort this in alphabetical order, what's the first letter that would be? It would be A, right? And then what's the next word? It would be N, I believe, right? And then T. So if we sorted that in alphabetical order, we would get that. So we sorted these in alphabetical. We sort nat and tan in alphabetical order, and we get and. We get the same word, right? So if we sort the word and we get the same output, then we know that they're anagrams of each other, right? Because they have the same characters, and so sorting it would just produce the same output. So what we can do is we can go through each word, sort it, and then keep a dictionary or a hash map, however you want to think about it. And we can do is we sort eat. which comes out to be an AET, right? So AET, right? And then this is going to be our key, because you know dictionaries are key value pairs, right? So you have a key, and then you have a value. So this is going to be our key, and then our value is going to be an array of, we'll just do it like this, an array of the words that when they're sorted, they produce this key, right? So hopefully you're starting to understand. So when we sorted eat, we got this string, right? So we're gonna place eat in here, and then what's another word? 8 is an anagram of eat. So if we sort 8, we would have a, and then this e would go before the t, right? Because alphabetical order. So then this 8 would go over here as well. And then we would do that for t as well. And then we would just do this for every word. So let's think about even tan. So tan would be tan, like I said here. If we sort it, it would be ant. So we would have another entry, another key value pair, which would start with ant. And then we're going to have an array of, I know this bracket should be down here, but this is just a rough picture. And then these two words are going to be in here. So nat and tan are going to be in here. And then eventually, once we're done looping through this whole array, we're going to have to loop through every element and sort it, and then place it in our dictionary. Once we're done, then we can just return the values of this dictionary, right? So overall, the time complexity is going to be, well, let's automatically think what's sorting, right? Sorting is log n time, right? Actually, I think it might be n log n time. Give me 1 second to clarify that. Yeah, so the worst case scenario for sorting algorithms is n log n. Okay. And this n is going to be the length of these strings, right? And I think it would be the average length of these strings. Okay, and then we're going to have to perform this operation for however many strings we have in this str. So we'll say that maybe this length of strs is s. So there's s strings. So it would be like s times n log n. And I think this is our time complexity. So it's big O of this. And then our space. Our space could be let's see. I think it would just be O of n, because this is really what's going to be taking the space, right? And at most, we're going to store every string in this hash map. So I think that our space complexity is O of n. So automatically, this isn't very good time complexity, right? But I think you could make this faster by using by not having to sort. Like if you didn't have to sort, then you'd automatically get rid of this and it would be a lot faster. I think you could probably like think of a faster way to figure out if words are anagrams of each other, perhaps maybe keeping like a count of each letter, kind of like what we did here, keeping a count of the letters and then using that. But for the sake of that, I don't want to get into that type of or that type of solution because it just take a little bit more time. So I'm just going to write out the solution. And I think you just have to keep in mind that this probably isn't the most optimal solution for this, but it works, and you could work on it to making it a little more optimal if you'd like. Okay, so yeah, so we're gonna have a hash map, and it's gonna be that, or it's basically like a dictionary, right? But you can call it a hash map. I think they're kind of synonyms of each other. So, and then we're gonna have a for loop. We're gonna say for word in strs, which is the array that we're given, and we're gonna say sorted word is equal to the sort. A string, you kind of have to do this funky thing where you do an empty string dot join, and then you do sorted of whatever string you want to sort. So this is going to be our word sorted in alphabetical order. And then what we can do is just basically say like, we want to populate, now that we've sorted our word, right? We've got our key right here, right? This is what our sorted word is going to be. This is our key. We want to either start a new array, an empty new array with this unsorted word as our first entry, or we want to, if there's already an existing array, we just want to append to the array, right? So we want to say if sorted word in hash map, basically mean if this sorted word is already one of the keys in our hash map, then we know that there's going to be an existing array for this key. So we don't want to just create a new array, we want to append to the array. So we can do hash map of sorted word dot append, and then we can just append word, right? Okay, and then what we can do is say else, this is the instance where sorted word isn't an entry, there's no key for this sorted word, so we need to just basically create an array with just this word in it, because it's our first value in this array. So hash map of sorted word is equal to, and then you can just create an array like that and just put this word, which is our current word in our loop. Yeah, and then what do they actually want us to return? They want us to return these anagrams grouped together like this, like a list of lists, right? So what we can do is, after this is finished, we're going to have a dictionary or a hash map that represents like this, and we're going to have, this is the information over here, right? The information that we actually want to return is over here in this column right here, this V. These are our values and these are our keys. We want to return our values here, so we can just say return hash map dot values. Oops. And yeah, realistically too, if you don't remember any of these functions, you could just look up, like I had to look this up beforehand. This was actually how to sort a string, but this one I think is how to return the dictionary value. So you can always just do a quick Google search to figure out what function you need to use. Yeah, and let's see if I messed anything up. Cool, yeah, that's that. Thanks for watching.